Hi, so this is your first video for chapter 11, which is all about limits. This is really, limits are really the jumping point into calculus, really the backbone for calculus. So my goal is to give you guys a little preview of what's going to be happening next year so that you can jump right in, get started from day one. Now, when we talk about a function, f of x, we are talking about a specific value for it. So f of x is a function's y value at a given x. So if I asked you for f of 3, you'd be looking for the y value when x is 3. So maybe it's something like 5. And then we could look on the graph or on the table and see that when x is 3, y is 5. There's an ordered pair for the function. A limit's a little different. A limit is also referring to a function's y value, but it's the value a function approaches for a given x. So you can see the big difference is it's not a specific value for the function. I'm not going to be able to say the ordered pair is this, but it's something that my values or that my function is getting really close to around that given x. So we're going to start by looking at some graphs today and see how that looks on a graph. And then we'll get more algebraic as the chapter progresses. So let's say I give you this little function. Looks like a nice little parabola, except that it has a hole where x is 5, and then an actual defined point below that. So it's probably some sort of piecewise function. If I asked you for f of 5, so the specific value for when x is 5, well, here's when x is 5, and it's defined for that extra point. So when x is 5, we would say that y is 1. So f of 5 is 1, and that's an ordered pair for this function. When I switch the terminology, though, and I say the limit of f of x at 5, I really don't care what's happening at 5. I want to know what's going on as my function approaches 5. And I'm going to consider it two ways. I would like to look at the left side of my function around 5, and I would like to look at the right side of my function around 5, and what those two sides are approaching. The left side is approaching a y value of 2. It may not actually hit it. It might not get there. That's fine. I don't care. Again, I just want to know what my function is approaching or getting close to. So the left side is getting close to 2. Coming in from the right side, I can see it's also approaching that value of 2. So that's how I can say that the limit of f of x at 5 is actually 2. It's not an ordered pair. It's just what my function is getting close to when x is 5. Notation-wise, we're going to see it written like this. You'll see LIM, meaning limit. Underneath it, you'll have your value that x is getting close to. So as x is getting close to a, your function normally will be defined. And then our answer off to the right, which is the y value that our function is getting close to. So for this particular example, it would be LIM, limit, as x approaches 5. If I had a defined function, I would put it right there. And we said that the limit as x approaches 5 is 2. So that's how we would write this in terms of a limit. All right, so let's take a look at a few graphs. Oops. And see if we can find their limits. All right, so first one is just a nice smooth parabola. No holes, no asymptotes, no breaks. Let's see what happens as x approaches 0. So again, I'm going to approach it from both ways, both sides of 0. Here I know is where x equals 0. So I want to follow my function in from the left side. Looks like that left side is coming down towards a value of -5. Then I'm going to follow it in from the right side. It's coming down and then scoops back up, also getting close to that value of -5. Since they're both approaching that same value, I'm going to go ahead and say that the limit as x approaches 0 of f of x is -5. And for this, because it is just a nice, smooth, uncomplicated function, you'll probably also note that f of 0, if I asked you for f of 0, that function value, it is -5. So it's okay that they're the same thing. And a lot of times that will happen. I just want you to realize that it won't always happen. Okay, let's go to the limit as x approaches 1. So again, I'm going to approach it from both the left side of 1 and the right side of 1. So here's where 1 is. So the left side of 1 is this guy right here. Looks like it's coming up towards -4. The right side of 1 is heading down towards -4. So again, it looks like they're both approaching that value of -4. So the limit as x approaches 1 of f of x is -4. And again, if I were to compare this to the function value itself, they are the same. Okay? All right, let's move on to this next guy. Next one looks like a little piecewise function, a couple little linear pieces to it. Let's start by finding the limit as x approaches 0. So again, 0 right in the middle. If I follow my function in from the left side, if I follow my function in from the right side, I can see that they're both getting close to that y value of 2. So I would say that my limit is approaching, or my limit has a value of 2. So as x approaches 0, y approaches 2. Okay, let's switch it up. Now I'm going to an x value of 1. Okay, here's where x is 1. As I follow my function in from the left side of 1, I'm at that top piece. Looks like it's heading up towards 5. As I follow my function in from the right side of 1, I have to jump down to that bottom piece, and it's approaching a y value of 1. Are they ever going to hit that same thing? No. We need to have one specific value for these left and right sides to be approaching. If they do not get close, if they're not going to meet up, then we will say our limit does not exist. So instead of saying no solution or undefined, in the limit world, we say does not exist, also known as DNE. And if you've ever seen Mean Girls, that phrase should sound very familiar to you. And if it doesn't, then you need to go back and watch. Okay, last one here. This last function looks like some sort of rational function to me with asymptotes, maybe a vertical asymptote for x equals 0, horizontal asymptote for y equals 0. I would like to find the limit as x approaches infinity. Now, hopefully you realize that when x is infinity, we're all the way at the right side of the graph, and there's no way to approach it from both left and right. You can't come in bigger than infinity. So I'm just going to think about my function heading out towards infinity. This will be left side only. Because I'm pretty sure there's an asymptote there at 0, it's never going to jump down and go negative. So instead, it's just going to kind of skirt along that x-axis and get really, really close to having a value of 0. Will my function ever have a value of 0? No. Do I care when I'm talking about a limit? No, because a limit is what my function is getting close to. This function is getting really, really close to 0. Let's move on to x approaching negative infinity. So negative infinity would be the opposite side as I follow my function's left side, heading out towards the left. Again, with that asymptote there, we're never going to cross up. We're never going to cross that x-axis. So it is also going to get super duper close to a y value of 0 without ever hitting, which is okay. Okay, let's switch to x approaching 0. So x approaching 0 would be the middle of my graph. The left side looks like it's heading almost straight down because, again, I'm assuming there's an asymptote there. The right side is heading almost straight up. So if the left side is heading down towards what I would think negative infinity, the right side is heading up towards what I would say is positive infinity, they're never going to meet at some specific value. They're not both approaching the same thing. So this would be a time when I would say the limit does not exist. Now, I've been using the whole idea of approaching something from the left side and from the right side. And really what that called is a one-sided limit. If we are looking at a two-sided limit, then we have to consider both, like we have been. But one-sided limits, we don't have to think about both. We can say just the left side or just the right side. If a problem is asking you to do that, you'll see in the notation either a positive or a negative after the x value. That little plus is indicating the side that it's coming from. So the plus is the limit from the right side of the graph. The minus is from the left. So when we say x is approaching 0 negative, it's from the left side, and that would be negative infinity. When x is approaching 0 positive, it's from the right side, and that's approaching positive infinity.